Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In electrophilic aromatic substitution, EAS, the directing effect of substituents determines the position, ortho-para versus meta, where the incoming electrophile, No2+, attacks. Meta-directors are electron-withdrawing groups, EWG, that destabilize the ortho and para intermediates, leading to preferential meta-substitution. Ortho-para directors are electron-donating groups, EDG. Moving on to the next step. A. Toluene has a methyl group, CH3, which is an EDG via hyperconjugation and induction. It is an ortho-para director. Nitration gives predominantly ortho plus para products, tilde 95%, with very little meta, tilde 5%. B. Aniline has an amino group, NH2, which is normally a strong ortho-para director. However, under acidic conditions, HNO3H2SO4, the NH2 group gets protonated to form NH3+. The NH3+ group is a strong electron-withdrawing group, EWG, and acts as a meta-director. Therefore, nitration of aniline under these strongly acidic conditions gives a significantly higher percentage of meta-product compared to the other options. C. Benzene has no substituent, so it has no directing effect. All positions are equivalent and give only one monosubstitution product. There is no concept of meta versus ortho-para selectivity. D. Isopropylbenzene, cumene, has an isopropyl group, CH3, 2, which is an EDG via hyperconjugation and induction, making it an ortho-para director. Nitration gives predominantly ortho plus para products with little meta. Moving on to the next step. Among the options, aniline, B, under acidic conditions, HNO3H2SO4 has its NH2 protonated to NH3+, a strong meta-director. This gives the maximum percentage of metanitroaniline product. And for the final step, toluene and isopropylbenzene are ortho-para directors giving mostly ortho-para products. Benzene gives a single product with no positional selectivity issue. Only aniline, due to protonation of NH2 under acidic nitrating conditions, acts as a meta-director and gives maximum meta-product. Therefore, the correct answer is B. Therefore, the correct answer is option B.